Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Welcome to my video. So in this video, we are going to continue our discussion for chapter 2, which is power in AC circuit. Okay, so my name is Dr. Nur Zulaili binti Muhammad. So this is my email address. So you can just feel free to email me whenever you have a question regarding the content of this video. Alright, okay. So the subtopics that we are going to cover in this video is only the AC waveform. Alright, okay. So for the topics of AC waveform, so what is the AC waveform actually? So it means that the voltage signal that is in the alternating current form, which is we call as the AC, that has a positive and negative cycle. Okay, so this is the example of the AC signal for voltage. Alright, so where you have a positive cycle and also you have a negative cycle. Okay, and then it will repeat again, positive, negative, and negative. Alright, so for the AC waveform, usually we normally refer it as a sinusoidal form. So this is we call as a sinusoidal form. Right, so the general equation for the sinusoidal form is a Vt is equal to Vm sine omega t. Alright, so Vm represent the maximum voltage. Alright, so the omega represent the angular frequency in the radian over second, and then omega is equal to 2 pi f. Okay, so the f is supply frequency in hertz. Okay, where the f is a supply frequency in hertz. So the t is the period. Okay, so t is a period in order to make it become full cycle. Okay, so in this case, one cycle consider until here. Okay, so t is from here to here. Okay, alright, so t is also can be represented by 1 over f. Alright, okay. So what is the phase? So consider when you have a AC circuit that have a capacitor or inductor in the circuit. So in this case, the current and the voltage do not peak at the same time. So it means that the current signal and then the voltage signal does not have a same peak, meaning that the peak does not happen at the same time. Okay, alright, so the period difference between the peaks expressed in degrees is said to be the phase difference. So for example, you refer to this diagram. Okay, so we have a solid line. So the solid line represented by V1, Vm sin omega t. Okay, so for V1, it starts at the point of 0. Okay, and then you have another signal which is represented by the dotted line. So the signal of the dotted line represented by V2 equal to Vm sin omega t plus phi. Alright, so in this case, you see the peak does not happen at the same time. Okay, so this is what it means. It does not peak at the same time. Alright, so there is a period difference between the peaks. Okay, so the period difference is given by this symbol, which is phi, and then we call it as a phase difference. Okay, alright, so usually when you have a Vm sin omega t plus phi, so it is a signal that leads the original signal by an angle of phi. Alright, so if you have a plus phi, meaning that the signal leading. Okay, because it started earlier here. Okay, meaning that the signal leading. But let's say the sign here is a negative. Okay, so negative meaning that the signal is lagging. Okay, and then this phase relation is often represented graphically in a phasor diagram. So this is your phasor diagram. In this case, you have a phasor diagram between V and I. Okay, and then here V is leading, I is lagging. Alright, so the angle between the V and I represented by delta. So in this case, delta is equal to delta of V minus delta of I. Alright. Okay, next we are going to see the concept of RMS. Okay, so the RMS stands for root mean square. So in AC circuit, current and voltage are generally stated as a RMS value instead of maximum value. Okay, and then the RMS is considered as the effective voltage that utilized in practical or theoretical analysis. And then the VRMS is usually given by the peak value divided by square root 2. In this case, Vm is represent the maximum voltage or the peak voltage. Alright, okay. And then next, let's have a look at the following example on how to interpret your AC signal. Okay, so consider you have a AC signal. It's given by the equation Vt equal to 141.4 sine 314t. Okay, so based on the equation, you need to determine the following. What is the maximum voltage? What is the RMS voltage? What is the frequency? So what is the period to complete one cycle? And what is the phase shift? Okay, alright. So the solution to the example, you refer to the equation. Okay, so you know this is the general equation of the sinusoidal voltage, where you have a Vt equal to Vm sin omega t plus phi. Okay, so this is your phase difference. So A, the maximum voltage. So the maximum voltage Vm. So this is your Vm. Maximum voltage is 141.4 volt. Alright. So next, the RMS voltage. RMS voltage is given by Vrms equal to Vm divided by square root 2. So in this case, 141.4 divided by square root 2 is equal to 100 volt. Alright. And then next, we need to find the value of frequency. Frequency is omega equal to 2 pi f. In this case, this is your omega. Okay, so omega t. So here is 314t. So in this case, this is your omega. Omega is equal to 314. So you need to find your f. So 314 divided by 2 pi. Okay, right. In this case, f is equal to 50 hertz. Right. So next, you need to find the period to complete the one cycle. So T is equal to 1 over F. So in this case, F is 50. So 1 over 50 is equal to 0.02 second. Right. So finally, you need to find the phase shift. Okay. So usually the general equation is given by sin omega t plus the phase difference or the phase shift. Okay. In this case, you don't have anything here. So that's why the phase shift is equal to 0 degree. Alright? Okay, so that is how you interpret your AC signal. Alright? So I think that's all for now. Thank you for your time and thank you for watching my video. I'll see you in my next video. Okay? Bye!